yesterday. So I'm Elmer Mojica. So our class time is Monday, Wednesday, although we could say it's 9:05 to 12:15. We might be online starting by 9 and we might be finishing by 12 because I cannot talk 3 hours straight. So if ever we have an in-person, my office is at W340. But since this is an online class, you can always contact me by email. So it's easy to remember. It's emojicalifornia at face.edu. Okay. So emojica at face.edu. So there's a textbook, but since this is summer, you're not required to have it. You can survive the course by just listening to the lecture and the recorded lectures that I have posted already ahead. And you don't need what we call the online web learning that we usually have during the semester. Because to tell you frankly, this is a very what we call intensive class because this is summer. We only meet for 10 meetings because the last meeting is, we could say, reserved for your final exam. So we seldom have 11 meetings in a summer session. Usually I have what we call 13 sessions, but because we are affected by the Memorial Holiday and what we call the 4th of July, so we lose 2 meetings during that time. Okay, so this is the tentative schedule. So since we have limited meeting, I decided that instead of giving you long exams, what I'll do is just going to give you a chapter quiz. So after we finish each chapter, you have a quiz a day after. Okay, so today we're going to finish chapter 1, whether you like it or not. Okay, and then there will be an asynchronous quiz that you're going to take using the Respondus lockdown. So I want you to be familiar with this Respondus lockdown. Okay, that's a proctoring software. Okay, wherein when you take the quiz, which should range from 30 to 60 minutes, you cannot use other browser and you are going to record yourself while you take the exam. Okay. Now, the way that we're going to do with the chapter quizzes, I already posted also some reviewers of questions, okay, similar to your quizzes. So I would suggest you work on them. And then if you're ready, the quizzes is open from, I think I put there 9 a.m. to 11:59 p.m. a day after. Okay. So I don't want to set a particular time because some of you are working. Okay. So I just set some sort of the whole day that you can take this what we call quiz. So as you could see here, we're really has a packed schedule. Okay. And there might be some meetings where we might cover more than one chapter. Let's say some chapters are a little bit longer than the other chapters. So what we do once we're done and we say we have still around 30 minutes, okay, we can go on the next chapter. And I also posted there in your classes the link of my lecture from the fall semester about Chem 111. They have the same material. The discussion might just be varied, but I think if you're going to look at it overall, they're just the same. So I would suggest you watch them before you come to the lecture. Okay, because most likely I'm just going to repeat it what I mentioned there. Okay, because what my student would tell me when I'm teaching the summer class, I give them some other lecture videos to watch. So they said they understand more the concept because when they watch it the first time, they might not have any idea about it. But when it was repeated again during the lecture, so they said now they understand what it's all about. So I would suggest try to do that. Okay. I'm not going to require the attendance. Okay. Because I'm going to post also the recorded sessions that we have here. So All of the date that we have here covers one chapter, but as I can tell you, if we can finish ahead, we will do so. Okay, especially the thermochemistry. But we will see. I cannot promise anything. Okay, because sometimes some of you might not be able to go on for 3 hours. But the thing that we could say is we need to finish at least a chapter every meeting. So the only one that you're going to have during class time in the exam is the final exam, which covers everything. Okay. So the requirements that we have a laboratory class that is asynchronous. So when we say asynchronous, we don't meet, but all the materials has already been posted in classes. And in fact, you have something to finish by today, a pre-lab quizzes about experiment 1 and the lab report of experiment 1. So you should have get an email from yesterday telling you about it. Okay. And in the laboratory, I think the way we did it is 65% is your lab report, 20% is your quizzes, and we're still finalizing these home experiments that you're going to do at home using everyday household materials. And then the quizzes, that's 50%. So it can have 11 items, 20 items, well, depending on the chapter. So what I'm trying to do, maybe by the end of the session, whoever got the highest total score, because I'm just going to what we could do it in terms of raw score. So we're just going to divide it with the highest total score. So let's say in the 10 quizzes and you have, let's say, 120 items and the highest is 110. So we're just going to divide everything with 110. Whatever your total score divided by the highest score. But that is really heavy. But the thing that I want it to be in terms of the quizzes so that there's a chance that whatever topic you study will be included in the quizzes, unlike in the exam. There's a chance the topic that you study is not included among the question. Okay? Now, the final exam is just a cover to cover thing. It covers everything, and it is what we call 25%. So those are the things that you need to survive the course. Now, before I what we call start the lecture, anyone has a question? Anyone? I'm not requiring you to show your face. I know some of you are not comfy. Okay, so I understand that. So if you don't want to say the question, you can type what we call in the chat. Yeah, if you have what we call any question. So what I'm going to do is, maybe you're familiar with where's that? So we have two classes. So the one that's 40119, that's the lecture. And the one that is 40120, that's the lab. Okay. So if you're going to look at the lecture, you will see that there's the syllabus that we have there, and we just discussed the syllabus indirectly. So I'm just going to show this thing to you. So this is how the syllabus looks like. So 50%, 10 chapter quizzes, 30 to 60-minute quizzes, and then the finals and the 25%. And then the laboratory is asynchronous. So we don't have a time for that. But if you have any question, you feel free to ask them during the question. Now the experiment quiz, it doesn't have a lockdown browser, okay? Because it's just a 10-minute quiz, true or false. So I think what you need to do there is you just read the materials before you take it, or have the materials with you while you're taking it. Okay. So the caveat that I did there is, yes, you're not going to do the lockdown browser, but okay, what happened is will be time pressure. Okay, sorry for that because I have a kid here who's doing also remote learning. So these are the experiments that you have. So what do you expect in this what we call lab? So if you're going to look at the classes, so you could see there, so this is the lab portion. So there's a lab manual, okay? That's the PDF file of all the materials that you need. And then you have the pre-lab quizzes that you need to take. That's also the whole day from 8 to 11:59, okay? And then in the lab experiment, what you could see there is link to YouTube videos which shows you uh, the experiment. Okay, and then you will see there's an experiment recorded lecture. So for you to see them, I suggest you download them because that's a recorded PowerPoint slides. So when you open it, okay, you will see there my voice saying something about the experiment. Okay, and then in most of these experiment, there is what we call a file named lab report. So what does the lab report has? It contains the data. Usually we call them the raw data. So all you need to do is to process the data that you have. So for instance here, so if you see this here, so you're just going to what we call use the materials that you have here. So do the process, and that's the one that you're going to submit as lab report. You do some sample calculation, percentage thing, and then you answer these what we call questions. In fact, we could say that you just accomplish these pages here. This is already your lab report. And then you're going to upload them. So as you could see, there is a portion there that I put as lab report. And I prefer you do it in PDF file. In one of the documents that I have, there's syllabus and documents, there's instruction for submitting the lab reports in classes. Okay. Now there's also a safety quiz that I made available until Monday. So this is the thing that you're going to do in the lab report. Now you can finish well ahead all the lab reports. Okay. I'm not going to stop you. If you want to finish by next week all the 12 lab reports, then fine. Because I told you this is done asynchronously. Okay. But I can only return it to you based on the deadline because I need to grade them all together. So no one will stop you from not finishing all the lab reports well ahead because I already put all the materials that you have there. But the quizzes, you have to take it on the day that it was assigned. Okay? So the schedule is written there in your syllabus. Now, as you could see here, in our lecture part, so I have here the PowerPoint. So this is the materials that we're going to use. I have here the link to the class recording. So if you're going to press this one, so what you have here, this is just the lecture part that we have during the fall semester. So this the material that you have there is the same as the one that we're going to discuss today. But I just want you to watch it. Okay, so when you hear the term there, and then you hear the term again during our class, you're already familiar what it is. It's not, we could say, the first time that you heard them. Okay, and I'm also going to what we call post whatever recording that we have during class. And then we have the chapter reviewers. So there's an example that we have. So each of them, you can use them to prepare yourself before the quiz. So you have some question there. And then at the end, there's the answer key that you have. Okay. And then when you're ready, so you could see there's the chapter quizzes. So quiz is already ready. The chapter 1 quizzes, it requires Respondus, Lockdown Browser, and Webcam. So it will start tomorrow, okay, at 9 a.m. and it's available until 11:59. So that's what we're going to, what we could do. So you need to have the proctoring software, Respondus. So all the materials that you have will be here in the classes. And if ever you have any question, you can ask now, you can type in the chat, or you can email me. Okay? So that will be our, we could say, routine for the next, if I'm not mistaken, 6 weeks. Okay? So questions so far? Uh, the one that I what we call discuss, usually that's the only one that you're going to submit in the lab. So usually in the lab, you just need to take what we call the pre-lab quizzes. That's a 10-minute quiz. Okay. Most of the question is true or false, and then you submit the lab reports in each experiment. That's all that you need to do. And then there's a home experiments that I'm going to post by next week that you're going to perform, and by before the end of the session, you're going to write a report about it. Okay. So the lab report is just usually processing of data and answering the question. So if we're going to look at the example experiment 1 lab report here, okay, so you just fill in the blanks here, the data that's missing, and then do some show some sample calculation here, and then answer the question here, and that's it. That's the lab report. You submit it. So question on that? No, the lecture is what we're doing right now. Okay? The lecture is we're going to meet Monday and Wednesday, but as I have told you, I'm not requiring you to attend. But what does study shows? If you attend, most likely you will understand. But this will be recorded. Okay? If you think waking up at 9 o'clock is hard for you, then that's your life. But if ever you don't do well because you're not attending the class, please don't blame me. Okay? So all I know, we're still in the pre-country. So if it's hard for you to attend the class in the morning, fine with me. Okay? But we are going to meet at least in the lecture because that's a synchronous one. That is scheduled as 9 to 12. Okay? Because I always believe in the mantra that some of you who have been my students before know that to survive this course, all you need to do is what? Do what the course said. And I know the chemistry is not a very popular one for you. Some of you dread it, some of you don't want to take it, and some of you are only forced to take it because it's a requirement. Okay? But all I say is just do it the way I tell you to do because typically students, they have their own way, and I can rearrange the letter in the word chemistry, and maybe by the end of the session, this is what you're going to say. So it's your call. Okay? So are we ready now? So the chapter 1 that we have is something to do with what we call the chemistry itself and measurement. Okay. So if you're going to look at chemistry, we can do it like this. I just need to pause because what happened is if I'm going to the definition of chemistry, if you're going to simplify it, it's just the study of matter. Okay. Chemistry is the study of what we call matter. But if you want to expand its definition, so we could say the study of the composition, structure, and properties of matter, and the energy and changes that matter undergoes. Okay? So anyone knows what matter is? What's matter? Anyone? Matter is anything that occupies space and has mass. So if you're going to look around us, everything is made up of what? Matter. Okay? So we could say chemistry is just the study of everything around us. And another term that you have there is what? Energy. So that's the ability to do work. Okay? So we could say if we're going to look at matter and energy, you combine them, just the study of yourself. Okay? And the antonym for that is M. That's my acronym. So it's how I would say the study of chemistry here is how you're going to overcome any anxiety that you have with yourself, okay, especially in science. And if I can be helpful to you, okay, because you say usually uh, the mentor is usually the tormentor of the student. So as I have told you, okay, to survive the course, you just do what the letters in the name chemistry says, chemistry. You're going to have a lot of, we could say, practice here. Okay? So just to give you an idea about the major areas of the chemistry, we have the biochemistry. That's the study of light at the molecular level. And then you have organic chemistry, the study of matter containing carbon and hydrogen. You cannot say it's just the chemistry of carbon, okay? Because CO2 has carbon, but it's not organic. And if you survive general chemistry, that's the next course that you're going to have, the so-called orgo. And then you have the inorganic chemistry, the study of matter containing all other elements. So usually that's what we have. That's what we're doing right now. Uh, General chemistry is just inorganic chemistry. Just I'm sorry for that. Okay. So most of the materials that we have belongs to inorganic chemistry. It's the study of matter containing all other elements. And then we have the analytic chemistry or analytical chemistry. It's analyzed matter to determine identity and composition. We have some components of that in this course. And physical chemistry attempts to explain the way matter behaves. So we could say this has something to do when we go to thermodynamics or thermochemistry. So those are the major areas of the chemistry. If you are chemistry, biochemistry, and forensic science majors, there's corresponding courses to it in the department. Okay. Now, just like we could say any science, chemistry is a science. So that means it follows the so-called scientific process. In other terms, they call it the scientific method. So when we have this scientific method, this is just a systematic approach to research. Okay? And usually the way that you do the scientific method, you have observation, and then representation, and then interpretation. So that's the overall idea that you have. So if we're going to look specifically the different steps in a scientific process, the first thing that we do is we observe. What do we use when we do observation? Anyone? What do we use when we do observation? Hmm? We use our five senses: sight, smell, taste. Okay. What else? The feeling and the hearing. So when we do observation, I would say we do we use our five senses. Most importantly, our eyes. Okay. And when we observe, what happened? We always ask ourselves a question. So let's say during the night you observe and you see the moon. So what's the possible question that will come out? What would the moon made up of? Okay. And then you try to find answer. Okay. Or maybe you can look for pattern recognition. So you always look at what we call the cause and effect. Every day, what do you observe? There's a day, and then after that, there's a night. So when there's a night, it's dark. So what can you tell yourself about it? Why is it we have a day and night? Okay. So the next thing that you could do is you can develop theories, and the low level of theories would start with the so-called hypothesis. Okay. So when you have a hypothesis, that is a tentative explanation. Okay. It's a tentative explanation for a set of observations. It is an attempt to explain an observation in a common sense way. So when you're looking at the moon, you may say, oh, it looks like cheese. So you might have an hypothesis that the moon is made up of cheese. And what you're going to do? You're going to test your hypothesis. Okay? And when you test the hypothesis in science, you do experiments. If you survive the hypothesis, okay, or if the experiments prove your hypothesis is correct, it becomes a theory. Now the question is, what is the theory? Okay, so a theory is a unifying principle that explains a body of facts and or those laws that are based on them. So we could say theory is just a body of facts, explains. Okay. Now, if your experiment proved that your hypothesis is wrong, you have to develop a new hypothesis. If your experiment proved that it is right, then you have what we call the theory. And what you're going to do is you go further, experimentation. Okay. So you may ask yourself, what is an experiment? So an experiment is an observation of natural phenomena called out in a controlled manner so that the results can be duplicated and rational conclusions can be made. So in an experiment, you control the factors that you have because you want to make sure that the one that you're looking for, the cause, okay, the particular effect is the one that is causing the effect. Because if you're going to change or have a variable factor, so most likely those variable factors, they are also causing the effect that you observe. Okay? So when you do an experiment, usually you do a series of experiments. And then from that, you can find some sort of relationship or regularity in the results. And after you do this experimentation, where you use to demonstrate the correctness of your hypothesis and theories, the one that come out, if the regularity or relationship is fundamental, we can simply state that it is a law. So when we're talking about the law here, we're talking about scientific law or natural law. This is not the legal law. Okay? So what we have here is the so-called natural law. So we have a law, it's a concise statement or a mathematical equation. Okay? It's a concise statement or mathematical equation about a fundamental relationship or regularity of nature. So what's a very good example of the law? Whatever goes up, okay, goes down. So that's the gravitational law. Now in chemistry, we have the so-called law of conservation of mass. So what does the law of conservation of mass tells us? So the law of conservation of mass states that the mass or quantity remains constant during any chemical reaction. So whatever is the mass of your reactant, that is also the mass of your product. So let's say you have two reactants that has 10 grams and then 10 grams. Your product will most likely be what? Around 20 grams. So that's the basis of this what we call natural law. Now, if we're going to look at in terms of mathematical equation, another example of a natural law is this one. PV equals to nRT. Anyone wants to know what's a PV nRT? Anyone has an idea what it is? This is what? The ideal gas equation. Now, based on this slide alone, there's a lot of questions that can be asked. Okay, so I would say you concentrate hypothesis, theory, and law. So usually we could say hypothesis, theory. Okay, that's the part where you try to explain what you observe. Okay, hypothesis, tentative explanation of some regularity of nature. Theory, we could say, is a tested explanation of basic natural phenomena. Okay, so this is how the scientific process works. And if we're going to look at some of them, I'll put you to, it's usually the experiment and the explanation that is the heart of the chemical research. Okay, so I have discussed with you about what experiment is, and then if the regularity relationship is fundamental, we can simply state it's a law, and a law is a concise statement of mathematical equation about a fundamental relationship or regularity of nature. So law of conservation of mass is the best example, at least in the chemistry world. If you go into physics, that's the gravity, the gravitational law. Okay? So an explanation, we have the hypothesis, tentative explanation of some regularity. If it passes, it becomes a theory. And a theory is a tested explanation of basic natural phenomena. Okay? So when everything is put together, that is the so-called scientific method. And scientific method is just what? Quite new. People were able to live without the scientific method before. Okay, Scientific method came only what? After the Renaissance? Okay. They have science before, but they don't call it science. They have chemistry before, but they don't call it chemistry. Since ancient time, they were all already has this what we call technology. But the problem is they cannot explain the science behind it. Okay? What's the first technology that we have? Anyone? You have the wheel and the fire. That's the first technology that humankind has. No one explained to them what they are, but they just use them. Okay? So an example of this so-called scientific method can be best illustrated with the discovery of so-called cisplatin. Anyone know what a cisplatin is? That's an anti-cancer drug. So Barnett Rosenberg in 1964 is doing an experiment, okay, wherein he used platinum wires electrode inserted into a live bacterial culture. So the variables that she controlled during that time is the nutrients that is being given to the microorganism, the temperature, and the time. And what he found out is the bacteria stop dividing. Okay? So whenever you use the platinum wire electrodes in the bacteria don't propagate. They cease dividing. They don't what we call live. So what she hypothesized is certain platinum compounds inhibit cell division. And he did some further experiments. He looked for some platinum compounds in the bacterial culture. He further tested the ability of these platinum compounds to test the cell division. And he found out the positive results of this material. So he was able to recover this platinum compound that was called cisplatin. Okay? And he found out in pure form that it can indeed inhibit the division of this so-called bacterial cell. So the theory was elevated, okay, from the hypothesis. So the hypothesis was elevated to the theory. So the explanation they had certain platinum compounds inhibit cell division. And what he do, she did further experiment to determine the anti-cancer activity of the platinum. So remember, it's just a bacteria. So when she found that it was able to inhibit the growth of the bacteria, okay, she applied it to the cancer cell or cancer cells. So he found out that it was able to inhibit the cancer cell. So it's one way of what we call the use for medicine. So what I have just discussed is this so-called scientific method. Okay. Now we go with matter. This is in terms of the physical state and the chemical composition. So as I have told you before earlier, matter is anything that occupies space and has what we call mass. And there are two ways to classify matter. One is by its physical state, like solid, liquid, and gas, and another one by its chemical constitution, whether it is an element, a compound, or a mixture. Okay? So let's go with the first one. And there's always one question on this slide. Solid, the form of matter characterized by rigidity. A solid is relatively incompressible and has a fixed shape and volume. Liquid, on the other hand, that's the form of matter that is relatively incompressible fluid. It has a fixed volume but no fixed shape. And then gas, That's the form of matter that is an easily compressible fluid. A given quantity of gas will fit into a container of almost any size and shape. But if we want to simplify these things, so we can go look at them here, how you see them macroscopically and how they are microscopically. And the best way for you to look at them is solid, liquid, gas. So you have to look them in terms of shape and volume. If I'm going to summarize the previous slide, solids are the one that has a definite shape and definite volume. Now the question is, why did we say they have a definite shape and they have a definite volume? Well, it has something to do on how they are arranged. They are arranged in a regular way here. So they're rigid, okay? The rigidity gives them the shape, and since they're close to one another, they gave them the definite volume. But when you go to the liquid, which is the only one that is definite? Anyone? Which is the only one that is definite? When you go to the shape, it's only now
Solid.
the volume. When you go to the liquid. Now, the shape of the liquid depends on the container. So we could say, okay, its shape is not definite. And you may ask the question, why? Well, it has something to do now with the distance between the molecules in a liquid. The atom or the molecules are a little bit far from one another. So they are not what we call tightly packed. Okay, so their shape is a little bit, how do you call it, out of shape, or they don't possess a regular shape. So they usually take the shape of their container. But the volume is still definite because there's still forces that hold the atoms or the molecules together. But when you go with the gases, okay, you could say that the shape is not already definite and the volume is not definite. And if you're going to look at the distance between the that they have, you can accommodate an extra atom or molecule in between. So that makes gas compressible. Okay? So that's we could say the easiest way for you to differentiate the three physical state. And I can give you an example of what's a solids and a liquid and a gas. Right? So if you go around us, anything that you see, so solid, okay, you can have it, the cell phone that you have there, that's a solid, okay? The materials that you eat, some of them, most of them are usually solid. Now, if you have the liquid, you can have water, okay? So usually the liquid, they need a container where you can put them. Now, for the gases, okay, so they have a container, but most of this container, you can compress them. Let's say if you have a balloon, okay, so the balloon, you can make them smaller because they have extra space in between them. You can compress them. Or another way for you to get an example of the three states of matter, just think of something that comes out of your body. I know it's gross, but I'm not going to say what they are. But there are three, what we call some stuff that comes out of your body that represents the solid, liquid, and gas. Okay? So that's an example of what we call the physical states of matter. And there's always a question on it, not only on your quiz, but maybe on your final exam. So that's the, we could say, advantage if you're attending the thing or if you watch the recording. Okay? Now, another thing that we can look at this is the changes that happen. So it can be physical or chemical. Okay? So how do we know one is physical and how do we know one is what we call chemical? So a physical change is just a change in the form of matter, but not in its form and not in its chemical identity. So if you're going to look at the physical change, before I go with the chemical change, we could say they are what? Reversible. So let's say melting of ice. So what do you have there? Ice becoming water. But you can reverse them. What do? You have water, you freeze them, it becomes ice. So melting of ice is a physical change. So whenever you have a physical change, its identity remains the same. No compounds are formed when you have what we call a physical change. And in some instances like this one, what can we say about the change? They are reversible. Okay? So it's up to you to identify whether a particular change is physical or not. Tearing a paper, is it physical or chemical change? You tear a piece of paper, is it physical or chemical?
Physical?
It's a physical because it's still made up of paper. Okay? So when you have a physical change, its chemical constituents are the same. There's no new compounds are formed. Now, compare it with the chemical change. So if you have a chemical change, there's a chemical reaction that form. Why? Because there's a change in the chemical identity. So a chemical change is a change in which one or more kinds of matter are transformed into a new kind of matter or several kinds of matter. Okay? What are the example of this what we call chemical change? Burning of paper. So if you're going to look at the chains that form new compound or element from the previous element or compound, then that's a chemical change. Okay? How about ripening of fruits? Is that chemical or physical? Anyone? The ripening of fruits. So that's usually a chemical. What happened there? Okay, I don't know if you think about it. Why is it some mango are sweet or banana, they're sweet when they become ripe? So the main reason there is the glucose that you have when they become ripened, it's breakdown to give you not glucose. The starch that you have, okay, they break down to give you glucose, giving you the sweet taste in banana and what we call mango. I think that's one of the household experiments that you're going to look at. Okay, so that's a chemical change. Now, for you, the typical questions that you're going to have here is which of the following is a chemical change? Which of the following is a physical change? So all you need to do is ask yourself, was there a new uh, compound or element that formed? Or is the chemical constituents before and after the change the same? So if they're just the same, that's a physical change. But if they're not the same, okay, most likely it is a chemical change. So a chemical change, whatever you have after the change is different from the one that you have before. Okay. Now, synonymous to this physical and chemical change is that what we call property. How do you define property? In human beings, how do you compare property in human beings? So we can call it as the characteristics. Okay. So characteristics can be used to describe person. Now property can be used to describe matter. Okay. And again, you have the wording here, physical and chemical property. So what does this mean? Okay. So when we're talking about physical property, these are just characteristics that you can observe in a given material without changing its chemical identity. Example, the physical state, solid, liquid, or gas. Okay. Water will always have what? H2O. Ice will always have H2O. Ice is a solid, water is a liquid, vapor is a gas. Melting point. Whenever we say melting point of water, what's the associated number that we have there? Anyone? 0 degrees Celsius. Okay? So water can be identified by its melting point. Melting point is just the same as your freezing point. Color. What's the color of water? Anyone? It is colorless. Right? So physical property, you can say it's a characteristics that you can observe without any chemical change or changing its identity. This is unlike the so-called chemical property. You can only observe this if there's a chemical change. What can we say about, let's say, oxygen? Especially how oxygen reacts with metals. And I think this is the explanation why we see the Statue of Liberty as what? Green in color instead of what? Statue of Liberty is made up of what metal?
Copper.
Copper. So what's the color of copper? Copper metal.
Brown.
Usually it's brown. But is the Statue of Liberty brown? Okay? The Statue of Liberty is not brown. It is what? Green. So can we say we still have copper there? Most likely not, but there's a chemical property that we can associate it on that. Okay? It's the so-called ability of copper to react with oxygen. And the term that we have there is oxidizability. Okay? So oxidizability, that is also the reason why we have this term rusting. Now, is rusting a chemical or a physical change? So if you are asked a question in your chapter quiz, is rusting a chemical or a physical change? Or which of the following is a chemical change? And one of the choices there is rusting. Are you going to pick it up or you're not? What is rusting? Is it a physical or a chemical change? Okay, it is a chemical change. Because what happened in rusting, you have a metal, so let's say copper, it reacts with oxygen, so you already have there a copper oxide. And this is different from that one. And we could say here, okay, if physical changes are reversible, usually chemical changes are irreversible. So that's another, we could say, difference between chemical and a physical change. Now, the chemical property, you can only see them after a chemical change. Okay? What else? Oxygen is also responsible for what? Flammability. So you cannot have reaction, let's say, of hydrocarbons with oxygen to give you CO2 and maybe water. So that's another, we could say, chemical property. Oxidizability, flammability. Okay, you can only exhibit, or what we could observe, this property after a chemical change. Hence, we call it a chemical property. Okay? So in your chapter quiz, you might be asked which of the following is a chemical property or a physical property. Or you can have a true or false set of statements, and you ask which of the following statements are true, as true, which of the following statements are false. Some sort of that. And I would suggest you look at the reviewer. Okay? Now, we go now to the different classification in terms of their chemical composition. So we go with element. So all you see here are element. So as you could see, most of them are what? Solid. The only exception is this one. That's a mercury, or the term that they use for that is what? Quicksilver. Quicksilver. So most likely this is a sulfur, this is magnesium, and these are other types of metal. So when you have an element, it's a substance that cannot be decomposed by any chemical reaction into simpler substance. So we could say element, there are the simplest matter. Okay? Because you cannot break them down simpler. Okay? So if you're going to look around us, there's millions of substance that has been characterized of this, a very small number are known as elements. Where can you find the elements? Or where can you find all elements?
The periodic table.
Okay? So all elements that we have is listed in what we call the periodic table. And I want you to have a copy of that. Okay? Because you can use it during your uh, chapter quiz. All you need to do is you show it at the beginning that you have that. Okay? So we could say, since this is the simplest matter that we have, so all elements are made up of an atom. That's the unit, the smallest unit of an element. Okay, there are, I think, 116 or 118 elements. Okay, but not all materials that we see around us are elements. The materials that we have around us are what we call compounds. So compounds are just made up of what? Two or more elements that are chemically combined. And what's the important element compound that we know? Anyone? What do you think is the most important compound around us? Anyone?
Is it water?
Yeah. The earth is made up of water. Our body is made up of water. If we don't drink water, we die. So we could say that's the most important element. And if they can find water in Mars, I think they will go there. Okay, and destroy that planet just like what we did. We destroyed Earth. Okay, so everyone wants to go to Mars if they found this what we call water on it, and then maybe just like what's that Matt Damon movie? They're going to grow potatoes on that place. Okay, so Most of the substance around us are compounds. And if we're going to look at the compounds, the smallest unit that we have, there's a molecule. So we could say water is a molecule. A molecule is made up of two or more atoms that are chemically combined. Now, what dictates the compound? It's the so-called natural law, okay, of definite proportions. So what does it mean? The law of definite proportion states that a pure compound, whatever its source, always contains definite or constant proportions of element by mass. So if you have pure water, whether it is in America, okay, in Antarctica, in Asia, in Arabia, it's always made up of what? 11% hydrogen and 89% oxygen. That's what the law of definite proportions mean. Okay? So H2O will always have this composition. Even the pure water of Flint, Michigan is made up of this. But if we're talking about polluted water, we're not talking about compounds anymore. So when we're talking about polluted water, you have water there that's mixed with pollutants. And that type of matter is what we call a mixture. Okay? So a mixture is a material that can be separated by physical means into two or more substances. So what does it mean? Okay? In addition to compound, I think most of the materials that we can find around us are made up of mixture. How do we differentiate the two? One, mixture you can separate by physical means. So for instance, this one, this is what we call the setup for distillation. How would you classify alcoholic drinks? Is it an element, a compound, or a mixture?
A mixture.
A mixture. How about the others? Everyone agreed that alcoholic drinks are a mixture. It's a mixture of what specifically? Water and
Ethanol.
ethanol. Good. So alcoholic drinks is a mixture of water and ethanol. Okay. Now, the amount of ethanol varies. Okay. How do you know the amount of ethanol in alcoholic drinks? They have this term proof. Proof is just a measurement of of ethanol in alcoholic drinks. How do you define proof? Anyone? Even though some of you may not be of legal age. Proof is just defined as the percentage of alcohol times 2. So when you say 80 proof, so that means you have 40% alcohol in your drinks. Now, how do you know it's a mixture? Because you can separate them using steam distillation. They have different boiling point, and boiling point is what? A physical property. So that means you can use that to separate them physically. So ethanol having lower boiling point, they will be collected first, okay, at a certain boiling point, and then after all of them collected, the boiling point will increase or the temperature will increase, and when it reaches the boiling point of water, water will be the one that is collected. Another way that you have a mixture is we could say if you have some plant components, okay, like a leaf, if you break them down, it's made up of different composition of compounds that you have there. The one that caused the blue color, the one that caused the green color, the one that caused the yellow color. And you can separate them by the term by this process of column chromatography. Okay. So what's the thing that you need to know here? You need to know how to classify a given material. Okay. And mixtures can still be further, we could say, divided as what? Homogeneous or heterogeneous mixture. So one thing that make mixture different from compound, mixture has variable composition. Compound has definite composition. And you can classify mixture either as homogeneous or heterogeneous. So when you have a homogeneous mixture, you just see one face. And you can make a mistake of saying that it is a compound because you only have, let's say, one face. Can you differentiate water from sugar solution by just looking at it? So if all of the sugar dissolves in water, you have a sugar solution. But if you have a glass of water and a glass of sugar solution, can you differentiate them by just looking at it? Anyone? The answer is no. What do you do? If you want to differentiate which is water and which is sugar solution, okay? Although this is not applicable in a chemistry lab, so one way to look at this is what? Maybe you taste. One of them will have a sweet taste, the other one will have what? Tasteless thing. Okay? Now the problem is if you don't have a sense of taste, right? So it's hard to differentiate, let's say, a homogeneous mixture from a compound or an element because you only see one taster. But if you have a heterogeneous mixture, it consists of physically distinct parts. So homogeneous when properties are uniform throughout. So what mixture is this? Is it a homogeneous or a heterogeneous mixture? Anyone? What what can you say about the potassium dichromate and iron fillings mixture? Is it a homogeneous mixture or a heterogeneous mixture?
Heterogeneous?
Okay, so it's a heterogeneous. Why? You could see that, oh, this is a little bit darker compared to this one. So that means there's some distinct parts. So you could say, oh, this is a magnet and this is what we call your potassium dichromate. How do you think you can separate them? Maybe you use a magnet. In addition of using the magnet, how do you think you're going to separate them? This is the one that you did in your lab. Maybe you what? Put them in water. So which one it will dissolve? The iron fillings or the potassium dichromate? If I put it in water, so what will happen? One of them will dissolve and the other one will remain undissolved. So which one remain undissolved? The iron fillings or the potassium dichromate? So this is just separating a mixture into the distinct compound or element.
Would it be the iron fillings?
Hmm?
Would it be the iron?
Okay, the iron will be the one that remains undissolved, right? And you might see your water there or your solution will become orange color. because it dissolves your potassium dichromate. So that's one way for you to separate it. If you have the magnet, so when you put the magnet there, all the iron fillings will go to the magnet. So the type of question that you'll be asked here is which of the following, or classify this. Okay. Now, if you have this so-called homogeneous mixture, if you have a homogeneous solution, homogeneous mixture that is another term that they have, that is usually you have a solution. All solutions are homogeneous mixture, but not all homogeneous mixtures are solution. So question, we already done with the first part of chapter 1, okay, which is about matter. Because remember, at the beginning of the session for this chapter, the title that we have is what? Chemistry and measurements. So when we're talking chemistry here, we're just talking about matter. So the next part that we're going to do, okay, so this is how you're going to separate them using magnet. Or before we go to the next part, just to summarize how we can differentiate element, compounds, and mixture, or in your own way, how are you going to classify a matter given to you? You have this set of questions that will guide you in classifying matter. Okay? So the first question that we can ask is, can you separate it using physical method like distillation and chromatography? Can it be split using physical methods? If the answer is no, then you have the so-called pure substance. If the answer, okay, we go first. If the answer is no, you have a pure substance. So when you have a pure substance is made up of element and compound. Okay? So pure substance can only be broken down into simpler compounds using chemical means, or you cannot break it down because it's already what we call an element. Because the next thing that you can ask yourself after answering no to the question, can it be split or separated using physical method? Can it be split by chemical methods? Okay, if the answer is yes or no, we have it as an element. If the answer is yes, we have it compound. Because water can still broken down by electrolysis to give you what? Hydrogen and oxygen. So this is a chemical methods. But if you have, let's say, H2 already and O2 there, you try to use some chemical methods, they will remain H2 or O2. So if it can be split by chemical methods, you have there a compound. If you cannot do it, so you have there an elements. And both of these are what we call, oops. I lost it. So both the element and the compounds are termed pure substance. Okay? So pure substance can only be broken down by chemical methods, not by physical methods. Now, if you have a mixture, it can either be a homogeneous mixture or a heterogeneous mixture. So maybe the question that you can ask here is it uniform? If the answer is yes, you have a homogeneous. If the answer is no, you have a heterogeneous mixture. So let's try to classify some matter. Dry ice. How would you classify dry ice? What is the chemical associated with dry ice? Anyone?
Is it nitrogen?
Nope. Ice is what? H2O. How about dry ice? Anyone who have heard dry ice? What is the chemical composition of dry ice?
Carbon dioxide, maybe?
Okay. So dry ice is known as carbon dioxide. And in Gen Chem 2, you will know why we call this dry ice, while water is called dry ice. So if you're going to ask yourself, can it be split using physical methods? The answer there is no. Can it be split by chemical methods? The answer is yes. Your CO2 can be broken down to give you C and oxygen. But you can only do it by chemical methods. So you can classify dry ice as what? Is it a compound or an element? Dry ice is a compound because you can still break down it by chemical methods. The answer is yes. How about vinegar? How are you going to classify vinegar? Anyone? If I have a chapter quiz question there, vinegar is classified as A, B, C, D. What's your answer?
I would say D.
Okay, D. How about the others? How would you
A.
classify vinegar? Okay, A. Now let's look at let's look at the composition of the vinegar. Vinegar is made up of what? Acetic acid and anyone? What's the other component of the vinegar? Water. Okay. Can you separate there by physical methods? The answer is yes. Acetic acid is the one that gives you the distinct smell of the vinegar, but they don't have a definite composition. They have variable composition. Okay, so that's why the correct answer, if you classify vinegar, is D. But if you are asked, how do you classify acetic acid? What is the answer? The same choices, A, B, C, D.
A.
Is it A? But you know, A is also equals to B and C. So which is the best correct answer if you
L
ask
B
this question?
C.
C.
It's C, because acetic acid is made up of this element. It's a compound that's made up of carbon, hydrogen, and oxygen. Okay? So those are the type of questions that you're going to encounter. So you have to ask yourself, okay, what's the composition of this one? Can they be separated? Because I told you, most of the materials that we can see, it's either a compound or mixture. Okay? Question? So I would suggest go over the reviewer that you have. So most likely, most of the topic that we have here will be covered in the quiz. That's why I want you to do as a chapter quiz. So when you study that portion, most likely it will come out compared to the exam. Okay. Now, the next thing that we're going to do, since we have a science here, we also do the so-called measurement. And the thing that we have to deal with this is the so-called significant figures. Okay. So before we go with this significant figures rule, oh no, I think I eliminate something on it. Just wait. Because in the glitch earlier, I might have eliminated something. I just want to make sure. If I'm going to close it, okay, I don't save. So if ever I'm going to open it again, I'm not going to close it. Yeah, yeah, so measurement. So whenever we make the measurement, okay, we usually do this thing, the comparison of a physical quantity to be measured with a unit of measurement. Okay, so what we do is we compare it with the fixed standard of measurements. So that's what we do with what we call the measurement. You're comparing, okay, anything to a physical quantity. Come to think itself, where do you think the term put came from? Put is a measurement of what? Anyone? This is a measurement of length. And literally, a put before means the size of a put. But the problem with put is what? Depending on the person, you have different length of a put, right? So what they do to standardize it, they set it as the length of a put of a king. But imagine if you're just doing trade, let's say you and Shaquille O'Neal. Do you want to be a trader or a buyer? Or you want to be a seller or a buyer? Because it says, whose put are we going to measure? Okay. So what they do is they set some sort of a standard. And whenever you do measurement, you're just comparing, okay, the one that you measured with that of the standard. So any unit of measurement, they usually have what we call standard. And the thing that they usually have in the measurement is the so-called precision. So precision is defined as what? The closeness of the set of values obtained from identical measurements of a quantity. Okay, so that is different with accuracy. So later on, we have a slide there that what we call differentiate accuracy from precision. Okay, now usually we can indicate the precision of a measured number or a result of calculation on the measured numbers. We often use this concept of significant figures. So significant figures, these are the digits in a measured number or result of calculation with a measured number that includes all certain digits plus a final one having uncertainty. So what does it mean? The first digits are certain, but the last digit is what? Uncertain. But both of them are significant. What do we say about uncertainty? What's the best word that describes uncertainty? Or you are uncertain with the last digits? It's some sort of an estimate. Okay? So the thing is now, what are these so-called rules on significant figures that you need to know? So the first thing that we need to know is the so-called, to count the number of significant figures in measurement, we have to observe these following rules. All non-zero digits are significant. So how many significant figures do you have here?
3.
So you have here 3 significant figures. All non-zero digits are, we could say, significant. Now, if we have this one, zeros between significant figures are significant. So how many significant figures we have here?
4.
That's 4. All of these are significant. So these are the questions that may ask you in the quiz. Now, zeros preceding the first non-zero digit are not significant. So how many significant figures do we have here?
Two.
Anyone?
Two.
2?
I thought 1.
1? What? Because you're given that number and you will have choices 1, 2, 3, 4. So it says your zeros preceding the first non-zero digits are not significant. So you have here zeros here, and they're preceding the first non-zero. So you could say this is the only one that's significant. So the answer that you have there is 2. Okay? Zeros to the right of the decimal after a non-zero digit are significant. So what does it mean? So maybe I can put it like this. So how many significant figures do I have? 1, 2, 3, 4. Anyone?
2.
2. Zeros to the right of the decimal after a non-zero. So you could say this is the decimal, so that means this is significant. But what do you define this zero? Isn't it the so-called captive zero in between? And captive zero are significant. So that means 1, 2, 3. Okay? So you have here 3 significant figures. So if you're going to look at the type of zero here, this is captive zero. This is the leading zero. And this is the trailing zero. And what does it mean here? zeros at the end of a non-decimal number may or may not be significant. So if you have 200, it can be one significant figure. If you want to make it into a 3 significant figures, what are you going to do to the 200? You have to write it in terms of this,
Decimals.
right? So that's what it means. Zeros at the end of a non-decimal number may or may not be significant. So for you to make this significant, you have to write scientific notation, because you can say that this has only one significant figure, the 200, because this may be significant or not. So if you want it to make significant, then you write it as scientific notation. Question? Before we do with the operation? I think this is the challenging question that will come out in your quiz. Not this one is straightforward, but the one where you do operation. So when we're talking about the number of significant figures, refers to the number of digits reported for the value of a measured or calculated quantity, indicating the precision of the value. Now, there are two rules that we have. When you multiply and divide measured quantity, you keep as many significant figures as the least found in the measurements used. We have a specific example on that, don't worry, okay? So what does it mean? You do multiplication division, so you look at the numbers that are given. Your final answer should have the same number of significant figures as the least significant figures of the given numbers. Unlike in addition and subtraction, okay, what you do is you give the same number of decimals as the least found in the measurement used. What does it mean? It has something to do with the decimals. But we will have a specific example here. Don't worry, okay? I'm not going to leave you hanging on your own. So let's say we have a multiplication and division. So if we want to clarify what the statement says here, the number of significant figures, the result is set by the original number that has the smallest number of significant figures. This one. How are you going to write this? Anyone? So you count here. 1, 2, 3.
It would be 16.5.
1, 2, 3, 4, 5. So that means your final answer, you're not just going to write everything that comes out in the calculator. Okay. 3 significant figures. So you have to write this as 16.5. If ever, let's say you have it like this, how are you going to write this?
16.6.
It will be 16.6. If you have it like this one, you round it up. No, 16.6, not 16.7, my fault. Okay, then we have another one. Division.
It'll be 0.1.
Okay, so you have your 2 significant figures. Is it 0.1?
Yeah.
You only have how many significant figures if it's 0.1? Isn't it you only have 1?
Okay, I get what you're saying.
Okay, so this is 0.061. Oops. Analyze because you have questions like this. Is the 2 0 here significant? Is this 0 significant? Both zeros?
No.
They're not significant. Okay? So the way that you're going to do is this one here. But since you have a 6, 9 here, so that means you round it up. So you think you can survive on that? So this is true for multiplication and division. You look at the least number of significant figures, and that will be the final answer that you're going to write. Now we go to the other one, the addition or subtraction. So the answer cannot have more digits to the right of the decimal point than any of the original numbers. So for instance, you have this here. So you have one significant figure after the decimal point. This one has 3. So the final answer should also have one significant figure after the decimal point. So how are you going to write that? $90.4. That's the final answer. So for this one, when you do subtraction, so the final answer should also have what? 2 significant figures after the decimal point. So you have here, how you round this up?
0.79.
79. So this one, if ever you do this thing, so this is 3, this is 4. So your final answer would be what? Whatever that one, 3 significant figures.
Is it 0.14?
No, because you have what? Look, 3 significant figures here. If you have 0.14, how many significant figures is that?
Just 2.
There's only 2 because this is not significant. Okay? So this is not the right one. This is the right one. Now, there are instances when we have this so-called exact number. So when you have an exact number, this is a number that arises when you count items or when you define a unit. So when you say define a unit, that's the conversion factor. Okay? So when we have an exact number, so when you say you have 9 coins in a bottle, you mean exactly 9. When you say there are 12 inches in a foot, you mean there's already what we call 12. So if you have an exact numbers, it has no effect on the significant figures in the calculation. Okay? Now you may ask, why has that no effect in the significant figures in the calculation? Because exact number is defined to have an infinite number of significant figures. So numbers from definitions or numbers of objects, they're considered infinite, exact numbers, and they have infinite numbers of significant figures. So if you're going to get the average of these 3, so usually the operation that you will have is like this one. And you're going to write the final answer like this and not 7. Why? What is 3 here? That is an exact number. So usually what I tell my students, I just tell them whatever is the given number, whatever the significant figures of the given number, then your final answer should have the same number of significant figures. So here all of them are what? Three significant figures, three significant figures, three significant figures. So if you get the average, it should also give you three significant figures. What are the exact numbers? Counting numbers and conversion factors. You're still with me? These are all numbers by now. So accuracy and precision. We always mistake them or use them for one another, but they're not the same. Accuracy is how close a measurement is to the true value. Like this one, everything is in the bullseye. The bullseye is the true value. So you could say it's accurate. Precision is how close a set of measurements are to each other. Since the shots or the hits here are also close to one another, you can call it also precise. Okay? Now for the second one, it's not accurate, but it's precise. Why is it not accurate? Because it's far from the bullseye, which is the true value. But it is precise because they're still close to one another. Okay? And then the last one that we have, if they're spread out, they're not accurate, they're far from the bullseye, they're not precise because they are far from one another. Okay? So that's the thing that we can have in terms of accuracy and precision. Now, if we're going to look at how we look at them, how do we measure accuracy? Usually we measure it by error. So error is just the difference between the true value and our measured value. Okay? So whenever we put an error, it has something to do with the accuracy. How far are you, or how far your measured value from your true value? Now, precision on the other one is just how close are your measured value. So we now go with SI units and SI prefixes. So in 1960, the General Conference of Weights and Measures adopted the so-called System International or International System of Units, which is a particular choice of metric units. Okay, and this system has 7 SI base units, and the SI units from which all others can be what we call derived. And what are these 7 SI units? This one: the length, the mass, the time, the temperature, the substance, the electric current, and the intensity. Now, the first 5 are the one that we use in Gen Chem. Length is meter, mass is kilogram, time is second, temperature is Kelvin, and the amount of substance is moles. And these are the symbols that you have. So these are what we call the base units. Now, if you do some operation in the base units, you can have the so-called derived units that we're going to discuss later on. Now, what does this mean? Why did we use the metric system? Compare, let's say, with the English system or the imperial system, as they call it. Okay? So it has something to do with the so-called base of 10. The advantage of a metric system, it is a decimal system. A larger or smaller unit is indicated by an SI prefix, that is a prefix used in the international system to indicate a power of 10. And these are the common one. Then you might ask me, do you need to memorize these? I would say no. The only one that you need to know is maybe this. When you convert from milliliter to liter, or the kilometer, the trees, and the 6. There are a lot. Okay, if you go, you have heard the giga, right? The tera. Those are prefix also. But this is the one that you use because of the base of 10 concept. Okay, the SI prefixes. And if you're going to look at the metric system, you could see everything is based on 10. Milliliters to meter, meters to kilometer, grams to kilogram, kilogram to a ton. But if you're going to use the one that we use here in the US, we are one of the, I think, 3 countries that still use the English system. So you have a 12 inches to a foot, a 3 feet to a yard, a 1760 yards to a mile, and a 16 ounce to a pound. Okay? So this is, we could say, the metric system compared to the English, or in some word, the imperial system. So there's logic here because it's just a smooth sailing thing. Here it's just like a roller coaster roads. So what's the first thing that we're going to do? We're going to look at the temperature. Okay. So one unit that we use is the Celsius. It's formerly known as the centigrade. And it's a temperature scale in general scientific use. But the SI unit is the Kelvin, because the Kelvin is based on absolute scale. Now, I think all you need to know is this conversion. K is just equals to Celsius or centigrade plus 273. Do you think you can remember that? Do you think you can remember this formula? Because you might need this formula for your quiz. And most likely I might not give this to you because this is just an easy formula or equation. Now there's another what we call unit of temperature, the one that we use here in the US, the Fahrenheit. So if you're going to look at the weather today, at least here in New York City, because not all of you are here in New York, it says we have what? 72 Fahrenheit. This is the conversion thing, but I don't think I'm going to give a question like this in the quiz. I just try to simplify the thing. And if you're going to put the scale side by side, this is what you have. So the water boils at 373 Kelvin, 100 degrees Celsius, and 212 Fahrenheit. And it freezes at 273 Kelvin, 0 degrees Celsius, and 32 Fahrenheit. But if you're going to compare them, okay, if you say a Fahrenheit 100 degree, it's really hot outside. That happens in the West Coast, like Arizona, during the summer. And we have a 0 degrees Celsius, it's really cold outside. But if it's a Celsius, 100 degree, most likely you're dead. And at 0 degree, it's just fairly cold outside. But in terms of Kelvin, 100 degrees Celsius, you're dead because that's so cold. And at 0 degrees Celsius, you're still dead because it's absolute zero. If I'm not mistaken, the conversion that I have here is just from Celsius to Kelvin and vice versa. So I limit already the thing there. Because what happened is you're not required to what we call memorize, so most likely the formula is given. Now we go with the derived units. Remember, we have 7 base units. Now, if you're going to make an operation of these base units, you have derived units, and you can have a lot of derived units. Like this one, speed. It's a derived unit of length over time, meters per second. So you just combine the SI derived unit, okay? Whatever's the SI base unit. So if you have volume, it's defined as length cube. So you have an SI unit of cubic meter. Although traditionally chemists use what? The liter. And a liter is just a unit of volume equal to 1 cubic decimeter. So we could say like this one. Okay. Now, if we're going to look at this, 1 liter is equals to 1 cubic decimeter, and 1 ml is equals to 1 cubic centimeter. And sometimes they put this, if you are, I think some of you are in health science, the word that they use is cc. And cc is just what? Cubic centimeter. So it's just the same as this one. Right? If you go in the medicine, if you go to the hospital, give him cc, 700 cc. Okay. Now, the main thing that we're going to focus in this derived unit is this one, density. I don't know why I write. So density of an object is just mass per unit volume. So we have this. So I think I'm not going to give this to you, but this is an easy one. So D is the density, where M is the mass, B is the volume. And generally, the unit that we use for mass is gram. And the unit for volume is ml for liquid, cubic centimeter for solid, and liter for gases. That's why you can have a unit like this, or like this. Liquid, solid, gas. And you can determine the relative density of mercury, of let's say a unit. So which do you think here is denser or more dense? Copper or mercury?
Mercury.
Okay. Anyone?
I also think mercury.
Mercury. Because what happened usually, the more dense is the one that is going to sink or in a lower. If you have different substances here, like this one, so if you say A, B, C, D, and you can say which has the lowest density. What is your answer there? A, B, C, or D? This one. So this is the one that is what we call less dense or least dense or the lowest density. Because what happens is the less dense material tends to float compared to the more dense material. Okay? So in terms of what we call, let's say I have 1 kilogram of gold versus 1 kilogram of feather, which is heavier? So what is your answer? Which is heavier? The answer is both of them have the same weight. But where is the difference between the two? The volume that it will occupy. Maybe 1 kilogram of gold, you just have a gold bar like this big. But 1 kilogram of feather, it might cover the whole room. So in that case, I can ask the question, which has higher density? So I told you 1 kilogram of gold versus 1 kilogram of feather. Which one has higher density?
The gold.
The gold. How about the others? Remember, we define density as this one. Okay, so if we're going to compare the two, they're the same mass. But between the volume, the gold has lower volume, while the feather has a higher volume. So if that is the case, this will give you a lower density, and this is the case that will give you a higher density. Okay? So let's try to solve this problem. So these are just all calculations now. So a sample of the mineral galena or lead sulfide weighs 12.4 grams and has a volume of 1.64 cubic centimeter. So what is the density of galena? So how are we going to write this thing? Anyone? What's the final answer here? Is it 7.6? Because if you're going to type the calculator, this is what will come out. 7.56097561. But how are you going to write the final answer? Anyone?
Would it be 7.56?
7.56. Why? You have three significant figures here. You have three significant figures. So the final answer should be three significant figures. Everybody got that? Now, once we know the density here, let's say I'm going to rearrange the problem. So what if I just put, let's say, a sample of mineral galena has a volume of no, I'm going to change that also. I'm going to put 20.0 cubic centimeter with a density of 7.56 gram per cubic centimeter. What is its mass? So how are we going to rearrange the thing? So you have density, mass over volume. So which one is given? You're given the density, you're given the volume, so you're asked for mass. So you rearrange it, you have density times volume. You might have questions like that. So you put there 7.56 grams cubic centimeter times 20.0 cubic centimeter. So your answer would be what? How are you going to write your answer? 151 grams. Although the one that comes out is what? 151.2 grams. Do you follow?
Yeah.
So the thing that I ask you to do is, this is what you have, but sometimes the one that is given is not like this. The one that's given is this one, or the one that's given is this one and this one. So how are you going to rearrange them? So how did I end up with this one? So D equals to M over B. So I was asked to do this thing. So all I need to do is multiply both sides by the volume. If it is the mass that is given and the volume that is the one that is being asked, so I can make it like B here, but I have to divide also with D. So I end up with volume equals to mass over the density. And I always not surprised if some of you have a hard time doing this thing. That's the what we call the mathematical skills. Okay. So if ever that comes out, because most of the question that you will get is at random. So there will be no the same questions in both of them. So let's go to the next one. So in addition to the physical and the chemical properties, we can also describe properties as extensive or intensive. So when we have a property that is proportional to the size of the used sample, it's called extensive. This includes mass, volume, length, and surface. So what does it mean? This property usually changes in terms of the size. So a 1 gram is different from a 1 kilogram, but both of them are extensive property, mass. Compare it with intensive property. So whatever the amount of your material, that property remains the same. Like density. The density of water is always what? 1 gram per ml. Whether it is 1 kilogram of water or 1 gram of water. Do you follow the difference between extensive and intensive property? And they said that intensive property just came from the operation of two extensive property like density. Density just comes from what? Mass over volume. Because what happened while they remains the same? As you increases the mass, the volume also increases. Okay? I have to take a call. Just sorry for that. It seems to be like an I thought it's important. It's just a dealer. Sorry for that. Okay? So if we go back here, intensive property is just due to an operation that is done between extensive property. Temperature is another what we call intensive property. So whatever is the amount of the material, it remains the same. Color is also what we call intensive property. Whatever the size of your sulfur, whether it's 1 kilogram or 1 gram, it's always yellow in color. Another thing that we can include is the boiling point, the melting point. It's always the same, whatever is the amount of water. Okay? Now, the last part of this chapter, and I think this is the challenging one, it has something to do with conversion units. Usually, we use the so-called dimensional analysis. So this is the conversion from one unit to another unit. And they said if you know how to do dimensional analysis, any problem that you have in chemistry, physics, or science courses is solved. Okay? So usually in performing the numerical calculations, it's a good practice to associate units with each quantity. And the advantage of this dimensional analysis approach is that the units for the answer will come out of the calculation. And if you make an error in arranging the factors in the calculation, it will be apparent because the final units will be nonsense. Example. Okay. If you're going to do, let's say, a dimensional analysis, or the one that they call factor label method. This is a method of calculation in which one carries along the unit for quantities. So for instance, you want to convert 20 yards to feet. So what's the starting point that you have? 20 yards. And what's the end point? Feet. So that means this is your starting point and you want to go to this. And what's the pathway that you have? The conversion of feet in yards. So how do we convert it? 3 feet over 1 yard, right? So if we have it here, what happened? The unit cancel out, leaving you with the feet. Now imagine if you make it the wrong way, like this. What will be the unit that you will get here? Oh no, I think this is the right way. Let's say I have a yard here and I have a feet here. So I will have yard squared over feet, which doesn't make any sense. So by arranging the unit that you have there, you arrange it in such a way you cancel the given unit, leaving you the desired unit that you have. So this is again what we call an exact number. So your final answer is 60 feet. So this is what you call your conversion factor. Now, In the exam or in the quiz, you'll be given the conversion factor. And if you have a conversion factor, the rule there is it's an exact number. Okay? So let's try to do this one. So I want you to get, using here, convert 0.547 pound to grams. So try to do it. Okay? Try to do a sheet work on this, and I'll be back while you're doing this stuff. So how are we going to convert this thing? So I can put here, so I have it here. So I can just put what right away? 453.6 gram over 1 pound. Is that the right arrangement?
Do you have to do the kilograms first and then go to grams after?
No, because I know that for 1 kilogram, I have what? 1,000 grams. So if you can do it, you can do it like this. But I just convert the kilogram here to
Oh,
gram
okay.
right away.
Okay.
But the way that you're saying is like this, but it's just the same as that one. I just saved one step of calculation, one less step. So if you're going to look at the unit, so the gram is the one that's left here. Here, pound, pound, kilogram, kilogram. I still have the gram. So whatever you use, you should have the same answer. So what's the answer? So what's your answer? Okay. Anyone? What did you get? Oh, I didn't see that there. 248. So question. So chapter one discussion is done, but I like to use the extra time here to give you some tips on how to survive the thing. Now, with the first question, are you ready for the quiz tomorrow, or you want it to be on Friday? I can widen the bid, the what we call the window for you to take the quiz.
Can we widen it?
Yes,
But
please.
but it's just for this week because after that,
Yeah,
it's
yeah.
because it's just the
Yeah.
first meeting. So I'm going to put the deadline there as Friday 11:59. But those of you who can take it tomorrow, take it. Okay. And are you familiar with the lockdown respondus? The respondus lockdown?
Yes.
Because I might have some people here who are not from Pace University. That's why I asked you in the introduction, why Pace? Because some of you, especially during summer, you're taking the courses, but you're not here from Pace. Because I was surprised with the answer. Well, I take it from Pace because I'm a student in Pace. Not all of you are from here during summer. I just want to make sure that everyone know how to use this what we call the respondus lockdown.